Yeah, good evening, everyone. Joining us, let's start off. Hope everyone has gone through the notes. Last time we were doing the two block problems. Let's start off with a problem and then we'll go back to three blocks. Like I said, three blocks are not exactly in the motion, but we will see one or two models just to get the hang of it. Let's see this question from Erido. It's a good one. Some of you are asking this as a doubt. Read the question, I'll explain. So we have an incline and initially it is projected with speed u. Coefficient of friction is mu. So this is your coefficient of friction. Erido they're using the symbol K. Angle is pi by 2. So he's asking find the velocity of the disk as it depends on the angle of pi. Just to show you the diagram, it was kind of like this. We'll turn the page. So this was that incline alpha. Someone projected the particle with speed v0 horizontally. And we know it won't go straight because of gravity. If you look at this in the side view, the forces acting on this body will be mg sine alpha. That is what will be dragging it down. Because of this guy actually starts going like this. Instead of going straight, it will start going like this. So at some point here, it will have a speed v when this angle is some phi. So he is asking, find this velocity as function of this phi. And this coefficient of friction is mu. If you look at this diagram from the side view, so this is that particle. You will find the forces are mg sine alpha. This would be a normal reaction. This would be your mg cos alpha. And understand, friction will be always opposite to velocity. The friction would be like this. I hope everyone understood the diagram, what is happening. So someone projected the particle horizontally from an incline. Like this, horizontally. It's supposed to go along the green line, but because of the mg sine alpha, you will drag down. At the same time, you also have friction. And remember, friction will be always opposite to the velocity because the wedge is at rest. So after going a certain distance down, it will make an angle phi. The question is find the velocity. Now, frankly speaking, this question, right, is not really that great one. It's a tough question because, there is a certain way to do it. Matlab, you need to, mug up the process. इसको ऐसा ही करेंगे तो आंसर आएगा types. Remember that cat dog problem? There is a particular way of doing the problem. There is, if you know the process, you'll get the answer. If you don't know the process, you won't get the answer. As simple as that. So there are certain types of questions like that. No, these things are not really innovative, or they're not really thought provoking. They're just like process mug karo, just go there and you know the answer, you get it or not. This is of something of that sort. But let's see, I'll do anyway. I try to explain this in more detail in the next page. So this is the diagram. This is the front view and the side view. Take a minute and then I'll show you. This is there in your PACE booklet also, but this is actually an Erudo question. PACE booklet, I think they asked you when it has become final velocity. That would be phi is equal to 0. Rona, please keep your cam on. Who else is missing? If you look at the forces acting on this, so initially this velocity is ux. I will consider this as my x-axis. I'll consider this as my y-axis. So along the incline is y and along that is x-axis. So it is going like this with an angle phi. And if you look at the forces acting on this, along the y direction, you have a force mg sine alpha. Right? And this is your velocity. This angle is also equal to phi. Now, let velocity be v. Make an angle phi with your y-axis. So we will write the equation along the y-axis. So you have to resolve the forces. Remember, the forces acting on this thing are friction, mg sine alpha, n and mg cos alpha. N and mg cos alpha will anyway balance. So we are just taking the forces only along the x and y axis. So if you take equation along y axis, the forces are mg sine alpha, component of friction f cos phi, that will be equal to mass into acceleration in the y direction. So this would be mg sine alpha, and we know friction ka value is mu mg cos alpha. This is cos phi is equal to may, and it is also given mu is equal to tan alpha. And the question it is given as k, but there is mu, same thing. So substitute mu here, you end up with mg sine alpha minus mu will be tan alpha, that will be sine by this. So this will be mg sine alpha into cos phi. So from here we get ay is equal to g sine alpha into 1 minus cos phi. This is your equation 1. Have a look at this. We get mu is equal to tan alpha. Tan alpha will be sine by cos. Cos gets cancelled and mg sine alpha comes out common. This question works just because that mu is equal to tan alpha. Hello, Shaditya, beyond time, guys. It's almost 10 minutes late you are. The speaker test is online, people, so do make sure to go through it. Any doubts on this step, please ask. If that mu was not tan alpha, you won't get the g sine alpha common. That's why I don't really like, like I said, it's not a really great problem. It is like a certain step and sequences you should know, or else you can't. Now, next equation. Now I'll just put on the same diagram again.
Sir, can explain how you got mu as tan alpha?
That is given in the question. If you read it, you'll understand. ये क्या था? Given na mu is equal to tan alpha. Yes. That means you didn't do this question in your Facebook letter. Mu is given everyone tan alpha. Now we will write equation along the velocity. That means you're trying to write the equation in the direction of v bar. Now this equation would be mg sine alpha ka cos phi minus friction is equal to m into acceleration. So this will be mg sine alpha cos phi. Friction is again mu mg cos alpha is equal to ma. And again mu is equal to tan alpha. You end up with g sine alpha cos phi minus 1 is acceleration. This is equation 2. If you observe equation 1 and 2, they kind of look similar. And these are the two equations. Please check the steps once. Look at the second equation. So we have to write one equation along the y-axis, one equation along the velocity. If you remember cat dog problem, we did the same thing. We wrote one equation in the horizontal direction, then one equation we wrote along the cat and dog ka velocity, line joining the cat and dog. So once you got these equations, again mu is tan alpha, so that becomes mg sine alpha. So we have ay is g sine alpha 1 minus cos phi. There is only acceleration in the y direction. Acceleration is g sine alpha cos phi minus 1. If you equate them, you end up with ay is equal to minus a. Ay is nothing but dy by dt. And this is equal to minus dv by dt. So we get dvy is equal to minus dv integral. Now understand, initially the speed was u, finally the speed was v. Initially vy was 0, finally the speed is vy. So we get vy is equal to minus u minus v minus u. And what is this vy? If you see this incline, this was your initial speed u. This was speed v. This was angle phi. This component was Vy. Vy is nothing but V cos phi. So V cos phi minus V plus U. We get V is equal to U by 1 plus cos phi. This is your velocity as function of angle phi. After a long time, this guy becomes almost straight. Phi becomes 90 degrees, 0 degrees. Then V final will become U by 1 plus 1, U by 2. So please check your steps. So main thing, you have to write the equation and equate them. Again, what I did, listen. First thing, the diagram. Getting the diagram itself is a big thing. If you look at all the forces acting on this is the side view. We have mg sin alpha dragging down the incline, mg cos alpha, normal reactional balance, and friction will be acting opposite to the velocity vector. So this guy won't go in a proper line, it will go in a curve. So that angle phi is changing here. Phi is variable. So at any point of time, let the velocity be v. So I wrote, along the incline as y-axis and the other line as x-axis, and then I took the components of forces along the velocity and component of forces along the y-axis. So this is the forces along y-axis. mg sin alpha and friction ka component in this direction f cos alpha, f cos phi is equal to may. You get only acceleration in the y direction. If I write the forces along the velocity, I get the total acceleration. This is total acceleration. And both the equations look kind of similar just because mu is equal to tan alpha, or else this wouldn't have been possible. And then you equated them, and initially Vy is 0, because all this velocity is ux, and initially Uy is 0. So the Vy ka limits will go from 0 to Vy, and speed ka limits will go from u to v. Integrate them, and you're done. And Vy at any instant will be v cos phi. Please check the steps. Now you should know that you have to do like this, or else there's no point in this question. Clear? Any doubts on this, please ask. Ritu, your cam's blank, right? Can't see you.
Going through the previous slide.
mg sin alpha cos alpha. You're taking इसका component है mg sin alpha का cos alpha component, right? You're taking force का components along the velocity. So angle between that velocity and mg sin alpha is phi. Clear with this picture? Check. Ask me if you're confused. Clear? All got this? Can I go ahead? Next one. Make sure to try this again. There's no other way to do this. At least I don't know. Click नहीं होता exam में. These things now, and if you get these kind of questions on the first time, these things don't click in the exam. You should have seen this kind of questions at least once. Next one. Let's get back to the two block problems. Mu s, mu k. It is there both on both the surfaces. Plot acceleration versus time graph. Get this. We have done this last time. Something similar, but this time I just increased up the mu s, mu k on both the surfaces. How do we do this? How do you start? Whenever there's a friction on the ground, first thing you need to ask whether this can move or not. So maximum friction on the ground is 0.3 into total weight 50 is 15 newtons. Meaning for time t less than 15 seconds, there is no motion only. Blocks are at rest. So the question starts from 15. Now how to do from there? So you start like this. For t greater than 15, assume both the blocks are going together. Find the acceleration, find the required friction, check if it is less than maximum. From there, you will get the time. After that time, they'll start slipping. So again, draw the new FBDs and solve. Meaning it's a repetitive process. Get this. Then we start like this. Assume for t greater than 15 seconds. Assume they go together. Now be careful, friction on the ground will be Fk. Because the moment you said they're going together, meaning the ground ka friction is, you have crossed the limit. You are slipping now. If you're slipping, friction will be maximum. So this guy would be mu k into the total normal reaction, which is 0.2 into 50. This would be 10 newtons. So you have to be careful. F is not 15. This is your acceleration. So t minus 10 is equal to 5a. So we get acceleration is t by 5 minus 2. From here, take any one block here. I will choose a 2 kg block. Remember, this friction is still static. Acceleration A. So from here, we get F is equal to 2a, which is 2t by 5 minus 4. This should be less than equal to mu s into n. That is 0.2 into 20. That would be 4. So 2t by 5 is less than 8. So that is 20 seconds. Hope I'm right. Yeah. So up to 20 seconds, friction can provide whatever you're asking for. So up to 20 seconds, they're going together. For t greater than 20, blocks slip. Blocks slip, therefore, all frictions have become kinetic. That's it. That is the only difference till now what we have done. The moment you say it is slipping, friction, you put mu k n instead of mu s n. So if you take the upper block 2 kg, this friction will be kinetic, which would be Fk is 0.1. So that is 0.1 into 20, which is 2 newtons. And this is the acceleration of this guy. So A1 will be 1 meter per second square. And for 3 kg, this friction will be 2 newtons and this friction will be 10 newtons. And this will be the force T. Let this acceleration be A2. So T minus 12 is equal to 3A. So this acceleration would be T by 3 minus 4. Please check these values here. You can clearly see here that T is equal to 20. Acceleration is 2 meter per second square. And here acceleration is 1. And if you put T is equal to 20 here, you get 20 by 3. That is 20 minus 12. A2 is actually 8 by 3. Keep the values, the red boxes in mind, so that next page when you draw, this will be useful. You need to find the accelerations anyways. But please have a look at this page. This is the process when you have mu s, mu k. Same thing which we did last time. Start with an assumption like, first you have to see whether they can move or not. Because there's a friction on the ground, they won't move for some time. So that is 15 seconds. After 15, they'll move. But the moment they move, friction becomes kinetic. Draw the new FBDs. Assume both go together. Find the friction required. So, and this friction should be less than equal to mu1. So friction is saying up to 20 seconds, we are fine. We'll go together. But after that, they slip. But the moment they slip, the friction between them also becomes kinetic. That's it. That change, you have to be careful. Any doubts on this page, please ask. Clear. Then, if you try to plot the graph, initially, it won't move. Now look at the problem here. Up to 15 seconds, it doesn't move. At 15 seconds, what is the acceleration here? At t is equal to 15, 15 by 5, we get acceleration is 1 meter per second square. So up to 15, they don't move. Then suddenly there is a bump, okay? They don't start from 0. They start from 1 meter per second square. That is because the friction value suddenly dropped. Both the blocks will suddenly get an acceleration, like a jerk. This will happen till when? Till 20 seconds. And the value will go till what point? 2 meter per second square. And then what happens? Suddenly the value will drop to 1 meter per second square. This is the main catch. Every time the slipping happens, the graph is discontinuous. The value is 8 by 3. That is 1. Na? Again, you come back to this value here. This is the acceleration of 2 kg block. So it is at rest till 15 seconds, then 15 to 20 it will increase till 2, and then after 20 it will suddenly drop to 1 and become constant. Whenever there is a slipping point, you'll always get a discontinuous graphs in US and UK. The other guy, it is 0. It will go together here. And then look at here. At t is equal to 20, the value is 8 by 3. The value will suddenly jump. And then it becomes more steeper. This angle is tan inverse 1 by 3. And this angle is tan inverse 1 by 5. Please check the graphs. This is how the graphs would look. Both will be flat on the ground, then both will go together from 15 to 20, and then they'll split. Because the friction value suddenly drops, you get a discontinuity there. This is actually a good hint, pata hai? Exam, if there are options, right? Whenever there is a US and UK, say I'll tell you one thing. In this thing, you know, first this will be slip, then this will slip. Matlab, slipping will occur 2 times. That means in the graph, there should be 2 discontinuities. So any graph with only 1 discontinuity or no discontinuity is wrong. How to calculate the angles? Equation of a straight line. Y is equal to mx plus c. So the slope m is equal to tan theta is equal to 1 by 3. Right? This is also y is equal to mx plus c. Tan theta is 1 by 5. The accelerations are straight line functions. That's how I'm getting those angles in case someone is confused. Please have a look at this. Main thing is this page. If you got this, the graphs you can draw. Please check. Clear with this, everyone? Next one. Look at the graph. So you have to check the values. T15, T less than 15, how it is? T greater than 15, how it is? So you have to check the values on before 15 and after 15, before 20 and after 20. The functions will change. You get discontinuity there. This happens because the friction value suddenly changes. The accelerations will suddenly get messed up. Clear? Next one. Any doubts? Vartika, Polika, clear? Neil, Arjun, clear? Ali, Mehan, Ritu, your camera is still blank. Ronak, got this. Udayan, clear, na? Ritu, so far all clear? Venkatesh, perfect. Next one. Two kg, 3 kg, 5 kg. Let's say F is equal to T. This is 0.2. This is 0.1 and the ground is smooth. Plot acceleration of the block versus time. Think how will you proceed? 2-3 minutes. I'll show you one model, then I'll ask you one more. I'll do one thing. Let me show you one model. Story is the same. Point is that the story will be always the same. You just have to understand where to change it. Assume all blocks go together. Now here, what can happen is maybe all are going together. Maybe one block is slipping. Maybe all are slipping. So there are 3 possibilities. So listen carefully how to do. I'll give you one more like this. I'll just change the numbers and all. You can do that. Assume all blocks go together. So we get acceleration. A is equal to F is equal to 10A. The acceleration is equal to T by 10. Perfect. Take the 3 kg block or take the 2 kg block. We get T here. Let this friction be F1 and this would be acceleration. So listen carefully here. So this will be T minus F1 is equal to 2 into A. A is T by 10. So we get F1 is equal to 4T by 5. Now this F1 should be less than equal to 0.2 into 20. That is 4. So T less than equal to 5 seconds. Yeah. So what is this F1 is saying? F1 is saying up to 5 seconds, I can make sure 2 and 3 will go together. Now understand one thing. F1 doesn't care what is happening between 3 and 5. F1 is a friction between 2 and 3. So this is saying up to 5 seconds, 2 kg and 3 kg will go together. That is the meaning of that. We have no idea what will happen between 3 and 5. Because F1 ka job is to take care of 2 and 3. It doesn't care what happens to 5. Right? Now you take the 3 kg block and the 5 kg block. You can take 3 kg also. The reason I'm taking not taking 3, right? 3 mein unnecessarily F1, F2 dono aayega. You can do it, but just lengthy. So if you take the 5 kg block, the only force who is pushing it forward is F2. Acceleration. So we get F2 is equal to 5 into acceleration, which is 5T by 10. This should be less than equal to 0.1 into 5. So this thing turns out to be less than 10 seconds. So this is saying up to 10 seconds, I can keep 3 kg and 5 kg together. Now, this is very hard to take a call. So that means between these two, who will slip first? The 2 and 3 kg, right? Therefore, this is wrong. So you have to choose whichever slips first, the other data becomes useless. So once we got this data here, so discard the data, whichever comes after this thing. So take the one with the minimum time. Take the case with minimum time and discard the other one. Or ignore the other case. You know why we are ignoring the other case? Why can't I just say 5 and 10? Reason, you derived this under what assumption? That all blocks go together, isn't it? Think about it. You got t less than 10 seconds under the assumption all blocks are going together. But at 5th second, 2 and 3 kg started slipping, meaning this assumption has gone wrong. Are you getting the logic why we discard the other data? The reason was this was derived under assumption all go together. That is not true anymore. 5 seconds में that thing started slipping. But t is equal to 5, 2 kg, 3 kg started slipping. That's why this data is discarded. Please check this page. Like I said, 3 blocks, little more steps. Now what to do from here? So up to 5 seconds, all are going together. Great. So we write the data. For t greater than 5 seconds, I'll turn the page again. Let's just see. 2 kg and 3 kg is slipping. Great. So assume 3 and 5 kg go together. Again, we start the story. Now it is become a 2-block problem. You don't know, no? 3 kg and 5 kg are going till what time? So now when you draw the FBDs, this guy F is equal to T. This is 2 kg. This friction has become maximum, which is 0.2 into 2, 4 newtons. And this is the acceleration. So we get acceleration of 2 kg will be T minus 4 is equal to 2A. Acceleration will be T by 2 minus 2. So now when we take these two, 3 kg and 5 kg, so the forces will be F1 max is equal to 4. Let this acceleration be A. So we get A is equal to 4 by 8. That is equal to half meter per second. But you need to check again whether they're going together or not. Take any one block. I will take the 5 kg block. This is friction F2 and this is acceleration. So F2 is equal to 5A, which is 5 by 2. This is your F required. This should be less than equal to how much? This is mu is 0.1. That should be 0.1 into 5. That should be equal to 5. So this is 2.5. Perfect. It is right. My assumption is right. So therefore, 3 kg and 5 kg are going together. Question got over luckily. Suppose if this also slips, so again we have to draw an FBD for 3 and 5 separately and do it. So I'll go back. I'll just show the final diagram. So if you try to plot the accelerations, initially all will go together up to 5 seconds. This will be the 2 kg guy. Luckily, we got a good answer here. Whereas these guys will become constant here. These guys also become constant here. acceleration of 3 kg and acceleration of 5 kg. That also could have got messed up actually. Please check the steps. Let me give you one more like this. Please ask me if you're confused with the steps. 3 blocks are kind of lengthy header. Like you just have to keep doing. You'll see the next problem even better. I'll make 3 and 5 kg also slip. That will be the worst case scenario. Venkatesh, Palaksh, camps on. Is this place clear, everyone? Look at this. So you have to first see who is slipping first.
So can you go back for a moment? Yes, sir, thank you.
Any doubts on this? Tanisha, clear now? Vastika? Clear? Yasha? Got this? Adrit? Clear so far? Aditya? Clear? And this is how the graph looks. Let's see the next one. The true power of 3 block problem comes when you keep the force in the center. Same question, I'll just not change the numbers. This time you're keeping F is equal to T in the center. 2 kg, 3 kg, 5. This mu is 0.2. This mu is 0.1. The ground is smooth. Plot acceleration time graph. If there's a 4 block problem, you will die again. You have to do like 4 times and all. Like you got the idea by now. You just have to keep checking who slips first and then continue doing it. Finish off this. Last one in friction. We'll start circular motion after this. Try. Start with the same thing. Assume all go together. Then See when will 2 and 3 slip, then see when 3 and 5 will slip. Whoever slips first, uska rako, and dusra get discard the data. Again, start with an assumption the other two guys are going together. See when they slip. This time you'll get all surfaces will slip. The graph will branch into 3 parts. Approximately, you can even guess how the graph would look. Huh? The graph would look like this. One guy will become constant. It will be like this. One guy will become constant. One guy will look like this. So having an idea what is happening can also help you to eliminate options. If it is an exam like mains or even advanced, at least 2 options you can eliminate. Saves you time. Like I said, guessing a question by seeing the data and trying to analyze what happens is the most superior form, but very difficult. You require a lot of knowledge and a lot of thinking. That comes after a lot of practice and seeing a lot of models. You start developing that kind of instinct. This I'm talking not when I was a teacher, when I was a student also. But takes time. You need a lot of practice because what happens is not only about practice. It should be very deliberate practice. So when you're solving question that you need to think, okay, in this question, what is happening? What else could have happened? Why should it be like this? Why, if I want it to be like this, what I should have done? This kind of, asking questions is very important. Most of you don't do that. You guys think what? Question solve kar leta, ho gaya. You think it is some kind of work pack, like, kaisa hai? Let's say your mom tells go and get some dhania. You feel like that. So लेके आ गया मैंने फेंक दिया मम्मी का फेस में अभी हो गया मेरा काम. It's not my headache. You guys solve questions like that as if it is like a chore. Like it is like something which you don't want to do. You just do it out of sheer with irritation. You do like ना खत्म कर लिया मैंने 20 क्वेश्चन का होमवर्क आज. That's the problem. You guys don't enjoy the process. That's why I keep telling you, for physics, right, you need not do too many questions. Per chapter, you do only 100, 120, but do them properly. Try to make new questions out of them. Meaning, just to give an example, sir, how to make new questions? कुछ नहीं करना है. ये है ना? I'll just put here f is equal to 2t. हो गया ना new question. I'll just put 2 forces. हो गया question, new question. You can do anything. I can put mu as mu. You can do multiple things. So keep this in mind what I'm saying. Trust me, this will take your physics to new heights. Most people think solve. They think they have to solve 1,000, 100 different questions. Not required. You take a selective models, right? Maybe like I said, for a chapter like friction, if you do even 80 to 100 problems, that is great. But then again, when you do, take your time and do aram se. Finish off the question. That is okay. Finish off the question in 6-7 minutes, and then take 2-3 minutes more to think like, yaar, isme aur kya kar sakte? What else is happening here? Why am I doing this way? If you don't ask those questions to yourself, you are just treating solving questions like some kind of work which you're not interested in. You will never develop that ability to think, and I'm telling you'll develop an instinct. When you see a question, you know what is happening. So keep this in mind when you're solving questions next time. Helps a lot. So if you want me to give some kind of way to do it faster, right? Weekly, right? Listen, this is a good one to try. Weekly, try to create 3 questions with options. You make 3 questions weekly. From any chapter that you have learned, make 3 tough questions, as tough questions as possible in physics. You make it. You can send it to me with options. I can analyze and tell you how good that question is. If someone can do this, it will be a pretty good exercise. 3 questions only, weekly 3 questions with options. Question अच्छे से होना चाहिए. If there's a diagram involved, diagram होना चाहिए, and there should be options given. If you can make 3 questions like this per week, I think this will help you to actually understand what the examiner is thinking. So someone is thinking, sir, you're telling to think and all, ye kaisa karna hai? I do understand. It is easy to say, but it is very difficult to implement that. Best thing would be try to make 3 questions. बस 3 questions per week. ज़्यादा भी नहीं है. If you can make 3 questions of physics every week and send it to me, I can analyze. I can tell you how good the questions are. If the questions are really good, I'll conduct them in some exam also. So someone who wants to do that, you can try that. Think about what I said. Chalo, how to do this thing. Just give it a try. I'll be just back in a minute. I'll get some water and come. Let's see. Sure. Let me help you out with this thing. Assume all go together. That's how you start. Now, I'm serious about these three questions, huh? Please do it and send it. You will really understand what I'm saying. Once you start making three questions, you'll understand like question making kaisa hota hai. You'll actually start thinking like whatever I'm saying, like how to make, what is happening in the question, why it is this, and try to make as tough as possible. That should be your objective. Make a question with as multiple concepts as possible, as tough as possible. Meaning, if most people can't do a question, you did a good job. That is the criteria, basically. So assume all blocks go together. So acceleration would be t by 10. So till here story is same. Take the 2 kg block. The one who's pushing is the friction of this guy. So this is the acceleration. So F1 is equal to 2t by 10, and this should be less than equal to 4. So this will be 20 seconds. Meaning up to 20 seconds, 2 kg and 3 kg will go together. Take the 5 kg guy. And the one who is pushing is F2. Acceleration. So F2 is equal to 5t by 10. This should be less than equal to 0.1 into 3, so 5. T less than equal to 10 seconds. Matlab, this guy is wrong. This data is wrong. You can discard the 20 seconds guy. So the first one to slip is 3 and 5. For t less than 10 seconds, all go together. That's the first data point we got. Please check. Now, some people, what they do now, they think 20 bhi ho jayega karke. But understand, you derived 20 under the assumption no one was slipping. You will see this number will change in the next part. I'll show you. That 20 ka data is wrong. Please check the steps. Clear? Next part. Minimum value is, yeah, minimum value is considered. Na? It's a solution, Monica. What is the meaning of this? If all go together, I will slip at 20. If all go together, I'll slip at 10. Did you get the meaning of the statement? But the moment you say, I'm slipping at 10, matlab this guy was useless, right? This was false, na? Making the statement? Yeah. So for t greater than 10, assume, so 2 kg and 3 and 5 are slipping. That is for sure. Again, we start the state. Now it becomes a 2-block problem. Assume 2 kg and 3 kg go together. So if they ask you 3-block problems, right? If at all they ask you, it will be mostly a matrix matching or a paragraph question. These are lengthy. Single choice question may take too much time. Then we draw a new FBD for 2 and 3 again. This F is equal to T. This friction is equal to 5. This is acceleration. This F is equal to 5 and this is acceleration A2 and A1. So A2 becomes 1 meter per second square. So 5 kg acceleration becomes constant. So this will be T minus 5 is equal to 5A1. So A1 will be T by 5 minus 1. Then again, take the 2 kg block. We have to check at what time this will slip. Again, this friction, acceleration 2 into A. That will be 2 into T by 5 minus 1 less than equal to 4. So T by 5 minus 1 less than equal to 2. That will be T less than equal to 15 seconds. Did you observe something? Actually slipping starts at 15 seconds. Previously data kitna aaya tha? 20 seconds. Because this was derived under the assumption, if everyone is going together, I would have slept at 20. But the moment the 5 kg slipped, you know what is happening, I'll tell you. Previously, what was happening now? This F1 is thinking, F2 will give how much ever I want. So it was under that assumption. That's why it was slipping at 20. The moment F2 started slipping, F1 has to provide more friction for all the blocks. So it will reach maximum value much faster. So for up to 15 seconds, they'll go together. So up to 15, 2 kg and 3 kg go together. After that, they slip. Please check this thing. So 0 to 10, all go together. 10 to 15, 2 kg, 3 kg go together. After 15, all are slipping. So वापस एक और FBD draw करना पड़ेगा. Put it up. So I think I can show you here only. For t greater than 15. I'll show it on the next page. I'll not scribble it here. But please check this out. This is how you handle 3-block problems. Go with a proper process, exam it, then you'll not get any tension, like you'll not blank out. The reason why you blank out is because you see the question and you don't know what the hell to do. But when you know a process, right, the moment you see 2 blocks and 3 blocks, idea aana chahiye, okay, in this kind of problems, this is what I do, this is what I do, this. You need to mug up the process, not the problems. And when you mug up multiple processes, so it's like you're having 4 to 5 different methods in your hand now, and you know all of them properly by hearted. So when a new problem comes, the new problem will be nothing but process 1 ka thoda part, process 2 ka thoda part, process 3 ka thoda part. So you'll know where to bring them and combine them. That is what you mean by thinking is. Normally how you train architect students, architects and all. So normally the best thing to do them, right? They bring them, they show them 100 different models and they tell them to draw all the 100 models or design all the 100 models already, which is built only. So आपको लगता है यार ये तो rut off कर रहे हैं, मतलब you're literally rut offing all the 100 models. But now when you tell them to create a 101th model, now you have inspiration from these 100 models. You take the best of every model from different situations and you make a 101th model. That is what is mean by experience. Instinct comes like that. So thinking is important, but before that, you need to ratify a certain level of knowledge. So, ratta marna, not a bad idea, not a bad thing. Problem ye hai, sirf ratta marna problem hai. You need to mug up things and you need to understand and you need to implement them. So don't even think like, oh, ratta marna, it is bad. I won't do that. I don't like, mugging up. That won't help. You need to learn how to mug up stuff. So then going from here, t greater than 15, two kg, this guy friction has become maximum, which is 4. So this acceleration is 2 meter per second square. 3 kg, this became 4, this became 5. This is t. This acceleration will be t minus 9 by 3. 5 kg तो anyway constant हो गया. This acceleration is 1. So if you try to plot this graph, up to 10 seconds, all are going together. This slope, let's call it alpha. Tan alpha is 1 by 10. How did I get? यहाँ पे slope देखो ना, a is equal to t, y is equal to mx. Then the acceleration is t by 5 minus 1, and this guy became constant. This is your 3 kg. No, 5 kg. Whose value is 1 meter per second square. Then this started going up like this. This angle is beta. How much is this acceleration? T by 5 minus 1. So tan beta is 1 by 5. They go like this till 15 seconds. Then this guy became constant. So who is this? This is 2 kg. और ये value कितना था? 2 meter per second square. The other guy goes like this, and then flies off like this. This angle is gamma. Tan gamma is 1 by 3. It becomes more steep. This is acceleration of your 3 kg block, the middle one. Check. That's how the graph looks. Any doubts on this? Please ask. Yeah. Any steps you're not convinced? That's how you handle the 3 block problems. Lengthy, takes time thoda, but yeah. Comes in the exam, you should be able to do this in 4 minutes, maybe 4 to 5 minutes. Now it looks difficult. First time you're saying, no, but after little practice, 4 minutes, you should be able to handle this. Brute force steps. This, then I'll do this, then I'll do this, then I'll do this. इसके ऊपर कुछ है ही नहीं. All 2 blocks and 3 blocks are like that. Okay, with that, we're done with friction. We have done almost 22 problems in friction. So make sure first thing, every class gets over, you need to revise the full thing again. When I say revise, do them without seeing it. That is one. Second thing, people who are scoring less than 50 marks in your classes exam or my exams, the reason why you're scoring less is because you're not revising the thing again and again. See, let's be very frank, okay? First thing, if you're scoring less than 50, somewhere you're having difficulty in understanding, you're struggling a bit. So what should we do then? We should revise the same thing once or twice rather than, running behind multiple books. So what some people are doing here, even though you're scoring less, so what are you thinking? You're thinking, yaar, mujhe aur zyada karna hai. You're thinking the other guy got 90 out of 100 because he did Cengage. That's the problem. You think that guy did Erudo, isliye zyada marks aa raha hai. So you think you should do all those books. It's actually the reverse way. First, you need to do the normal work properly, multiple times, at least once or twice. Then you'll cross 50, 55. Then we can think of more. So don't run behind books. Don't run behind too much material. Take 1 book, 2 book maximum and do them thoroughly. HC Verma I solved 3 times. Erudo thoda kiya because my time there were no books. And imagine I cracked advanced ka subject to paper with HC Verma. I scored almost 110 out of 180. It was one of the toughest physics paper. My maths and chemistry were dump, but वो अलग story है. I think 280 में सिर्फ 110 is physics only. And paper was tough. 282 था out of 555. JEE 2006 advanced paper. Something of that sort, roughly you got around that. Okay, so with that, we are done with the friction part. The next one is circular motion. I'm telling you, your first source should be your class ka notes. My notes, your classes ka notes. 2 notes you have. That itself will have total combined, I'm sure. At least friction jaisa chapter mein, they must have done at least 20-25 problems like me. I did 22, so at least 40 problems to wahi pe hai. So first do your class ka notes properly, thoroughly. Then you do your classes ka booklet. Time permits, then you go for my book. Ho gaya, then again do everything again once more. That would be much better than doing different things. Great. Next thing, circular motion. Circular motion has 3 parts. First, the circular kinematics, uniform circular motion, and non-uniform circular motion. Again, the chapter is really not that difficult. It looks like laws of motion. We'll see. In uniform circular motion, there's only one concept you should know. If you got that, again, draw an FBD, write the force equations, write that equations, and solve. The story will be always the same. So today we will handle circular kinematics. So in circular kinematics, we just like, kinematics, we take velocity, position, and acceleration. Here we define something called angular position. Theta. So angular position is angle made by the position vector. With respect to the reference line. Most probably, you can actually take this as a reference line. So reference line is something which you can choose. This would be your position vector r bar. This is your angle theta. Every time it need not be a circle. You could have even taken some random path. So this is your observer. This is your position vector, and this you can take it as a reference line. So you can choose any point as reference. This angle theta would be your angular position. So angle with respect to the reference line. So here we define something called angular displacement. Delta theta, which is a vector, which is theta final minus theta initial. Remember, this thing has a direction. If you rotate, we use right hand thumb rule. If you rotate anti-clockwise, this is plus k cap. Hope you remember the right hand thumb rule. If you rotate your fingers in the direction of that thing, when you make a curl, the thumb indicates the direction. If you rotate clockwise, this is minus k cap. So just to give an information, basically this is a pseudo vector. You guys remember what's a pseudo vector? Pseudo vector is not real. It gives you the sense of direction, but in case you forgot, we have done this in detail in pseudo vector here, page 64 vectors. So whenever, this is the direction of rotation. If you curl your fingers, my voice is cracking.
No, sir.
Aryan wants to check your connection, right? Might be from your side. So if you take your hand and if you make a, fist, if you curl your fingers, this will give the rotation. The thumb will give the direction. So this is not the actual, what do you call the actual direction. It gives you the sense of rotation. So example, if someone tells you 2 revolutions per second k cap, iska meaning ye hai, put your thumb along k cap and curl your fingers. So I will leave it to you here. So page 64 vectors, you can refer that. More about pseudo vector there. Refer page 64 vectors. We did that in more detail there. There, angular displacement is a vector quantity. Now here R bar need not be constant, okay? R bar ka magnitude can change. It doesn't matter. We are only interested in the angle. Angular position, angle with respect to the reference line. Clear? Now here, certain thing. If a particle completes one revolution, displacement is zero. So we will start using the word linear displacement, okay? Not to get confused with angular displacement. Linear displacement is zero. So if you make one revolution, you start at the point and you came back there, it is zero. Whereas the angular displacement is not zero. Angular displacement is 2 pi. So linear displacement, angular displacement are different. So how to get angular displacement zero? We can make this zero by rotating 2 pi in the opposite direction. If you want to get a zero angular displacement, you have to rotate in opposite direction. Think of like this, basically it is based on the screw. If you rotate in this direction, the screw will come out. So the screw is out of the plane. If you make this rotate in this direction again, the screw will go inside. So then we say angular displacement is zero. Clear? Just have a look at this once. Yeah. I hope this was clear, everyone. If you make one revolution, linear displacement is zero, but angular displacement will be 2 pi. If you rotate it in the opposite direction, it will be, what do you call it? Zero. Please check. Can I go ahead? Malika, Vartika, clear? Abhinav, go ahead. Next one. Angular velocity. The symbol is omega. So just like, position, this is rate of change of angular displacement. Rate of change of angular position. That's why you call it circular kinematics. It looks exactly like kinematics. Only thing everywhere you keep putting angular, angular, angular. So this omega is given by d theta by dt. Omega average. Remember average velocity? Final position minus initial position by time. So delta theta would be integral omega dt. So if someone plots a graph between angular velocity and time, this would be the area under omega t graph. Area above the x-axis is positive. Area below the time axis is negative. exactly what in kinematics, everything is valid. Also, if you take a theta versus time graph, in a theta versus time graph, the slope gives you the omega. Please check. Clear? Now, here we can actually relate this to the velocity. If you take a circular motion, this would be your S arc length. This is theta. We know S is equal to R theta, and if you differentiate this on both sides, we have a particle going in a circle with radius R. We get ds by dt is equal to R d theta by dt, assuming R is constant. This ds by dt is the tangential distance, so this becomes V tangential is equal to R into omega. The vector form V tangential is given by omega cross R bar. Vector form is this, magnitude is V is equal to R omega. Be careful, it's not the full velocity, only the tangential velocity is equal to R omega. Clear, everyone? Let's see some questions before going ahead with more theory. There is more theory. So using this thing, right? Actually, even though I showed it for a circle, you can do this for something different also. Can I turn the page? Suppose if you have two particles here, let's say this is u1, theta 1, this is point A. This guy is u2, theta 2, point B. So if you stop velocity with respect to B, you have done this in relative motion. This velocity will look like u1 sine theta 1 minus u2 sine theta 2. This would be u1 cos theta 1 plus u2 cos theta 2. This is point A, and this is point B, which is at rest. So this will think I'm at rest. Now you tell me which velocity is responsible for rotating. This is responsible for changing the direction, isn't it? In relative motion, we ignored it. This is actually your V tangential. And this velocity is responsible for bringing them A and B together. So from the definition we got here, omega is V tangential by R. So this becomes U1 sine theta 1 minus U2 sine theta 2 by D. So what is this exactly? This is angular velocity of A as seen by B. So B will think A is going with this omega. So I can even find omega for two particles which are moving. Stop one of them and then see the velocity. Angular velocity of A as seen by B. So from here we can write a general formula. Omega is relative velocity perpendicular to line joining the 2 points. So join the line and take the perpendicular components relative velocity. By distance between them. This is a general formula for two particles. So if they give you two particles and they ask you find angular velocity, this is what we can do. All clear with this? So actually you can find omega in multiple ways, okay? You can find theta as function of time and differentiate, or you can actually find the V tangential and divide by distance. So there are two ways of doing them. So let's see a few problems and then I'll show you both the ways and you see whichever you like, you can do. Generally, this thing saves you a lot of time. Can I turn the page? Aryan, clear so far? Niranjan? Got it? Ali? All clear? Ritu? Rehan? Clear.
Yes, sir.
Neil? Let's see a question. A particle is projected with u and theta. Observer is standing at the point of projection. Find omega of the particle as seen by the observer when it is at h max. Now, in case you're thinking what is happening, I'll just explain you. Listen, sir. This is the projectile, right? Initial, how is the vector? When the particle is here, this is the vector. 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 Isn't this angle changing? Angle is changing, no? Understand one thing, When I say angular velocity, I don't care about distance. I don't care about length. I don't care. I just care only about the angle. Isn't the angle of this thing changing? It is rotating, rotating, rotating. There it is rotating. There it is rotating. Are you getting how the angle is changing? I'm not interested in the length of the vector. I'm only interested in how much angle the vector is rotating. So the question is, when it's at the h max, the highest point, at what rate that angle is changing? Get this projectile in circular motion. In case you thought kinematics is over, yeah, welcome back. Nothing is over in physics. Every damn chapter will come in every other damn chapter. Even when I teach you the 15th or 16th chapter, you'll get everything from chapter 1. Recently, I was teaching your seniors magnetism. That is like almost we're on the verge of finishing it off. 3 chapters left for them. They forgot vectors. I started taking concepts from vector components. It was fun. Let's get this. Circular motion is interesting. The only thing, right, have an open mind. Whatever you learned in school, forget about it and come. Then you will understand that circular motion pretty easily. School they taught you a lot of hopeless stuff on circular motion. Sometimes I feel, the only good thing about the school is, friends. Other than that, most of it was shit only. I don't know. I could be wrong. I think friends was one. At least my time, though, it was fun. Maths class and bio class were fun. Remaining subjects, I hated it. Yeah. Physics was hopeless. Our teacher used to teach. I don't know what physics is that. We used to play games also. It was fun. I used to be a big prankster in the class. So whatever teacher used to teach them, we used to play that games. So one day teacher was teaching about a black hole. So we started playing a black hole game. You know what is a game? So the thing what I understood from black hole is anything that comes close by will get pulled in. So what we did in the break time, so 3 people are sitting on the bench, 3 people are sitting on the bench. We turned both the benches. Whoever is walking by, catch them, pull them inside and beat them. Black hole game. That is what I understood about a black hole. The gravitation is so high, it pulls everything inside. So we 6 people used to sit there and whoever is going beside, catch them and pull them and beat them. And we used to say black hole, karke we used to shout. Acha game tha, until we pulled Sudhir, who was pretty strong. He destroyed the black hole and went away. So we stopped the game after that. Then social teacher started teaching World War I and World War II. I was Germany. Full fight. I don't know why the hell I don't know why I was Germany every time, but we should take, rubber bands and paper things and start hitting everyone. It was fun. So we used to play a lot of stupid games like that. Abhi to people don't have time. You want to play games, so you'll just open your phone and download PUBG and fight. Chalo, what is the answer? Anyone? Answer is complex. It's not answer nahi hai. But it is easy to do if you understood what I was teaching till now. Let me teach you both the ways, okay? One mathematically, which is quite lengthy. But let's see what is true. So this guy is flying here. So what we do here now? At any instant r bar, this coordinate will be x comma y. This angle will be some alpha. So we get tan alpha is equal to y by x. X is u cos theta t. I'll not solve this. I'll just show you what to do and we will leave it there. U sin theta t minus half gt square. And then differentiate this guy. You always first have to do it in a variable, okay? Don't directly take h max. Differentiate with the time. So tan alpha will be secant square alpha d alpha by dt. And this guy differential, that will be pretty messed up. That would be dy by dt 1 by x minus y by x square dx by dt. So this d alpha by dt, this is omega, isn't it? Rate of changing alpha. And then you can substitute time is equal to 2u sine theta by g. That will give you the answer. It's pretty long. Find alpha as function of time t and differentiate. That will give you d alpha by dt is omega. Let's see a better way. Now, this is the first method. Mathematically, find theta, differentiate, and get everything. Please check what I did. Ask me if you're confused. Because you said the rate of change of angle. So basically, rate of change of this angle is omega. As this vector is going, which angle is changing? This angle is changing. When it is at this angle is changing. So I need to differentiate the angle which is changing. Angle. So here, meaning I took the ground as reference line. You could have chosen vertical also. Won't matter. Any doubts on this? How to do it normally? The other way around. See, alternately. This is using that V tangential ka concept. So understand one thing, both are right. We are just doing the same thing in two different ways. So from here to here, this was your R bar. At this point, the velocity is u cos theta. This is your R bar vector. This angle was your alpha. This was alpha. This component would be u cos theta sine alpha. This is your V tangential. And we know at h max, this distance will be r by 2 and this will be h. This is small r. So small r will be root over h square by r by 2 whole square. Omega is defined as V tangential by radius. V tangential is u cos theta sine alpha by small r, which is root over h square plus r square by 4. And what is tan alpha? Tan alpha is h by r by 2. Please check. Numbers are given. This would be faster actually. Differentiation kuch nahi karna hai. And do you guys remember what is this component? I told you this will come again. Anyone remembers? Where did we do this? First time we saw that as in vectors actually. The first question in vectors, remember dr by dt? The rate of change of length of vector. The u cos theta cos alpha is the component which is responsible for changing the length of the vector. This, no, I think first time you encountered this in vectors actually. Vector, I think we did calculus, I guess. First we did vectors, no? Yeah. We saw that in calculus only, the kinematics only. Okay, you saw that, so you remember. So basically, this guy would be d mod r by dt, the rate of change of length of vector. So there, that was rate of change of length of vector, and this was v tangential. Have a look at this. Clear? Next one. Next one. Again, I'm telling you, see, there is no need to do, new problems. You can do the same problem and you can play around with multiple things. We have a rod of length L here, angle theta. This is point A. A is pulled with a constant speed u. Find angular velocity of the rod. So that theta is changing now. A is pulled with constant speed u. If you remember this thing, we have done this in constant motion. Find omega of rod at this instant. In case you're wondering what is happening, this is how the diagram would look now. Initially, the rod was like this. After some time, the rod would be like this. After some time, the rod would be like this. So basically, the theta is changing there. So the rod is rotating. So this theta is variable. Find angular velocity of the rod at this instant. So theta, in terms of theta. Get this. Again, you can do it in both the ways again. I'll show you both the ways. But end of the day, you decide one which you like and you fix up with that. There's nothing wrong with any one method. This is what I'm saying. You need not look around for different questions. Whatever you have done, you can make them only more dangerous. Try. This is a little easy though. Anyone not clear with anything, please ask. Polar, not like that. Ronak, that's not the answer. No, that's not the answer. Any answers? We have one answer, but that's not right. You can type to the chat co-host here. First thing, let me show you with the calculus one, then the other one also. Now this thing, the tangential one becomes more lengthy. So this is a rod. This is theta. Let this distance be x. This is a, right? U, and this is L. So cos theta is equal to x by L. Differentiate on both sides. Minus sin theta d theta by dt is equal to dx by dt into 1 by L. D theta by dt is omega. Dx by dt is u minus u by L sin theta. Negative indicates theta is decreasing. Omega will be minus d theta by dt since theta decreases here. हो गया एक step में answer. Just cos theta and finish it off. Now, if you look at the alternate way, this rod is there. This is point A. A is going with U. This would be VB. This would be theta. This would be 90 minus theta. You know from rigid body constraint, U cos theta is equal to VB sin theta. So आएगा VB is equal to U cot theta. And remember that formula? You have to take the components. U cos theta, U sin theta. This would be VB sin theta, VB cos theta. So omega का definition be relative perpendicular to the line joining them. So U sin theta minus of minus VB cos theta by L. Means you should take the components which are perpendicular. I'll mark them with green color. These guys. Because that is responsible for rotation. VB cos theta. If you substitute that VB ka value and do na, you get U by L sin theta. This is also right. So you can use either method, but this case differentiation makes your life easy. There, henceforth we will use any one method only. So you guys can take a call which one you want to use. You could have basically to find omega, you need 2 points at least which are moving and uska relative velocity along the line. Even 1 point is moving, so it's fine. You can take relative tangential velocity and finish it off. Sometimes it clicks, sometimes it doesn't click. So both the methods are quite useful. Clear with this? Please check. Any doubts on this? Next one is a homework problem. Make sure to try it at home. It's a good one. I want to give some time to try. And the best thing, you have seen this already. Like I said, we'll not do any new things. 3 particles ABC chasing each other. Remember the story? Chase each other with speed U. Side of the triangle is A. And I'm sure you remember how the diagram looks. This is how they rotate. So here O is the centroid. So if you take this point OA here, so I can ask you like this thing. So first question. So what we observe here is we see ABC always form a triangle which is rotating and shrinking. Dekha word aaya rotating. ABC form a triangle which is rotating and shrinking. So the first question, find angular velocity of the triangle. The triangle is rotating, so that also has omega. Find angular velocity of the triangle at time t. Angle rotated by the vector OA bar after time t. Basically, it is the same thing as angle rotated by triangle. It's a good question. I can add something more also. Find area of the triangle at time t. That is not circular motion actually. But ठीक है ना, it is there, so we'll just dump it there. So try this question and come for the next class. So give it a try, and we have done this problem in kinematics. You can refer that for more. And I told you, when this thing comes, I told you it will come again. And this thing has all the data. This is the hint, page 228. So refer that, you'll get the ideas from there. Especially in this, now, this second one is a good one. Find the angle rotated by the OA bar vector. I hope you remember the path. A ka path will be like this, spiral. So find the angle rotated by that vector after time t. So try this next class as a homework. Don't forget this. First thing in the class next week, we will do this problem. And then we'll continue from here. Right? If you have observed, right, I showed you 3 problems which I have already done before. We just made it rotation. Okay. So with this, we'll wrap up for that day. So this week a test is already online till Tuesday. So make sure to give it NLM. Right? And any doubts in today's class, anything, please stay back and ask. Also free to leave. So take care, stay safe. I'll see you guys again next Wednesday as usual.
Bye, sir. Thank you.
Bye, sir. Thank you.
Take care.